Hey there, how's it going? So today we're going to talk about finding all asymptotes, any asymptotes. When they say all, they mean any. So very briefly, let's refresh our brains upon the three asymptotes that we look for. The very first one, the most important one we always search for, is the vertical asymptote. That's where your denominator equals 0. The second asymptote is the horizontal asymptote. We are going to look at the numerator's lead term over divided by the denominator's lead term. And then last but not least is the oblique or slant asymptote. Those two words are interchangeable, so just FYI. We look for an oblique or slant asymptote when there's no horizontal asymptote. We have to use long division to find the oblique or the slant asymptote, and it must be linear. Good? Okay, so let's put these into practice over here. The first one we're going to look for is the vertical asymptote. Now, the vertical asymptote comes from the denominator. With me? So my denominator in this case is x plus 4, and it must equal 0. So I'm going to take the denominator of x plus 4, set it equal to 0, and solve. And so now I have a vertical asymptote of x equals negative 4. Now, when you graph it, it's a vertical line. It's linear. Are you with me? Keep that in mind. It's linear. Got it? Okay. By the way, there is one exception to finding a vertical asymptote, and in the examples to follow, we'll look at that. But for the time being, I'm keeping it very simple. With me? Okay. The second asymptote we're going to look for is the horizontal asymptote. Now, in order to find the horizontal asymptote, we say we take the lead term of the numerator. So here's my numerator. What's the lead term? 3x over the lead term of the denominator, x. And now I'm going to reduce it because it is a fraction, right? Once you reduce it, bringing in a little bit of calculus, we're going to look at the limit as x approaches infinity of the reduced form, which is 3. Now, as you keep plugging values in for x here, what does the y start approaching? Because that's basically what you're looking at. This now is y equals, because f of x and y, in this case, we're going to just replace it. So instead of f of x equals this whole thing, we're going to look at y equals 3x over x, which is 3. So what would y equal when you take the limit of 3 as x goes to infinity? You're like, well, there's no x's there. You're right, there are no x's there. So is this value of 3 ever going to change? You're right, it will not, which means in this case, the limit of 3, a number, as x goes to infinity, is just 3. So in this case, your horizontal asymptote is y equals 3. It is a horizontal line. It's linear, once again. Are you with me? Okay. And now, the oblique asymptote, or the slant. Remember, the oblique asymptote occurs when there's no horizontal. Do I have a horizontal? Yes. Therefore, can I have an oblique? No. And again, in the examples to follow, you will understand why you cannot have both of them. But for the time being, I'm just keeping it very simple. Are you with me? Okay. So, your vertical asymptote is a vertical line, x equals negative 4. Your horizontal asymptote is a horizontal line of y equals 3, and there's no oblique asymptote. Remember what I said, it must be linear. These two are linear, this one's also linear. Got it? Okay, so I have some examples to follow as I mentioned. Work on them before you find my answer key video. You may find that you did most of the examples correct, just a little tweaking here and there, and that's okay. Keep these 3 in mind, and I'll leave them up on the board as well so we can look at them as we work. Good? Okay, have fun with this stuff. Catch you on the flip side.